Hey there, Seahawks, it's Miss Adams, and in this video, we're going to talk about random variables. All right, there are two types of random variables, discrete random variables and continuous random variables. Discrete random variables, we can list all of the outcomes, so there's only certain values that are possible. For example, the outcomes of a dice roll, the number of heads in 3 coin tosses, the number of children in a family. Okay. Continuous random variables can be any value in a range. Okay, so we're not going to be able to list all of the possibilities. For example, the number of hours a light bulb lasts before burning out, and then time to run a mile. So there's going to be like decimals. Okay. The basics. A random variable assumes a value based on the outcome of a random event. So we use capital letters like X to denote a random variable. A particular value of the random variable can be denoted with a corresponding lowercase letter. A probability model for a random variable consists of the collection of all possible values of the random variable and the probability that it occurs. The expected value of a discrete random variable can be found by summing the products of each possible value by the probability that it occurs. So you take each value, you multiply it by its probability, and you add it to the next value times its probability plus the next value times its probability, and that will give you the expected value, which is really the mean. All right. For data, we calculate the standard deviation by first computing the deviation from the mean and squaring it. We do this with discrete random variables as well. So the variance for a random variable would be x minus mu quantity squared times the probability, and then add up, so the summation of all of the events. Okay? And then the standard deviation, we would take the square root of the variance. Okay, standard deviation is always the square root of variance. All right, transforming random variables, adding or subtracting. A constant from data shifts the mean but doesn't change the variance or standard deviation. So if you add or subtract a constant, it's going to adjust the mean but not the standard deviation. And we've talked about this same thing before. Multiplying each value of a random variable by a constant multiplies the mean by that constant and the variance by the square of that constant. All right, two random variables. The mean of the sum or difference of two random variables is the sum or difference of the means. Okay, so I can add and subtract the means and I'll get the sum or difference. If the random variables are independent, the variance of their sum or difference is always the sum of the variances. Okay. The standard deviation is the square root of the sum of the standard deviation squared. Okay, standard deviation squared are variances, so it's the square root of the sum of the variances. Okay, with standard deviation and variance, with your spreads, you're always going to be adding. All right, in your calculator, to find the mean and standard deviation from a probability distribution, you would put in list 1, the values of the variable, so in the top row of your table. In list 2, the probabilities of each value, the bottom row of your table. And then you would go to stat calc, you do one variable statistics for list 1, and then your frequency list would be list 2. Okay, and that would be finding the mean mu and the standard deviation sigma. Okay, and if your mean says x bar, cross that out and change it to a mu because you want to be sure that you're using either mu or e of x, so like capital E of x expected value. All right, so some reminders. E of x is the same as mu of x. Standard deviation is the square root of the variance. Standard deviation is the square root of your standard deviation squared. And variance is standard deviation squared. So all those things kind of work together. You'll need to use them. Example 1, let's play a game. You pay $5 to play. In the game, you get to draw one card from a standard 52 card deck. If you draw the Ace of Hearts, you win $100. If you draw any other ace, you win $10. If you draw any other heart, you win $5. Any other card, you win nothing. Okay, we are interested in the amount that you gain. Create a probability distribution. So X is going to represent the value of the variable, so the outcomes. And then P of X is going to be the probabilities of those values, and we want to make sure that they always add up to 1. All right, so we're interested in the gain. If I win the $100, well, I spent $5 to play the game, so my gain would be $95. If I win the $10, my gain would be $5. If I win the $5, my gain would be nothing. And if I don't win anything, my gain would be negative $5. Okay? The probability of getting that $95 gain, well, if you get that, you can only draw the Ace of Hearts. Well, there's only one Ace of Hearts in a standard 52 card deck, so 1 out of 52. If you draw any other ace, well, if I draw any other ace, there's 3 other aces out of 52. The next one is if you draw any other heart, okay? So there are 13 hearts, and one of them is already used, so 12 hearts out of 52. And then any other card, okay, so you want to make sure that it's not already being used up, so that leaves us with 36 out of 52 that are not aces or hearts. All right, so now I'm going to use this table. What is the chance that you go home with at least some money? So the probability that X is greater than 0. Okay, so that would be 1 out of 52 plus 3 out of 52. I either go home with $5 or $95 if I go home with some money. And I can add those, and that gives me 452. What is the chance that you gain at least $10? Well, if you gain at least $10, the only one is the $95. So probability that X is greater than or equal to 10, the only option I have is the $95 gain, which I have a 1 in 52 chance of winning. What is the probability of not gaining any money? Okay, the probability that X is less than or equal to 0 would be the probability that I gain $0 or the probability that I gain negative $5. So 12 out of 52 plus 36 out of 52, which is 48 out of 52. All right, example 2, find the mean, which is the expected value, and the standard deviation. So you have a probability distribution. You can plug this in your calculator. So list 1 would be 0, 1, 2, 3, 4, 5. List 2 would be 0.05, 0.12, 0.18, 0.2, 0.4, 0.05. Stat calc 1, list 1, and then your frequency list, list 2. All right, your mean, if you worked it out, it would be your X value times its probability, plus the next X value times its probability, plus the next X value times its probability, plus the next X value times its probability, and so on, which gives you 2.93. And the standard deviation, if you worked it out, it'd be the square root of your X value minus the mean squared times its probability, plus the next X value minus the mean squared times its probability, plus the next X value minus the mean squared times its probability, and so on, which works out to be 1.306. All right, your turn. What is the expected value and standard deviation of example 1? So what we did for example 1, here's the probability distribution. What would be the expected value and standard deviation? So see if you can pause this and figure it out on your own. All right, you should have gotten a mean of negative $1.35 about, and a standard deviation of $13.80. All right, example 3, a new game. You are rolling a die. You are again interested in the amount gained. it costs $5 to play. If you roll a 6, you win $10. If you roll a 5, you win $7. If you roll a 3 or a 4, you win $5. If you roll a 1 or a 2, you win nothing. Create a probability distribution and find the expected value and standard deviation of the game. All right. Okay, so I could win $5, $2, $0, or negative $5. Again, I'm only worried about the gain, so I have to subtract $5 from everything because I'm paying $5 just to play. So if I gain $5, that means I won 10. The only way I can get that is if I roll a 6. Well, a die has 6 sides, so that's a 1 out of 6 chance. If I win the $7, that's a gain of 2. I had to roll a 5, which again is 1 out of 6. If I rolled a 3 or a 4, I would get $5, which is a gain of 0. Well, that was 2 options, 2 out of the 6. And if you want to reduce the fractions, you can, either way. And then if you roll a 1 or a 2, that'd be 2 out of 6 for the gain of negative 5. And then if I want to find the mean and the standard deviation, I could plug that into my calculator, or I can work it out. 5 times 1/6 plus 2 times 1/6, and so on. You should get those values. All right, example 4. Random variable x has a mean of 6.2 and a standard deviation of 3.1. Find the new mean and standard deviation if we multiply by 3. All right, so mean of 3x would be 3 times my mean, which is 18.6. So if I'm multiplying, I can just multiply the mean. Standard deviation, if I'm multiplying, I can just multiply the standard deviation. So 3 times 3.1 is 9.3. Find the new mean and standard deviation if we subtract 10. So the mean of x minus 10. So for the mean, I'm going to go ahead and I can subtract 10. I get 3.8. For the standard deviation, if you add or subtract a constant, it doesn't change it. Okay, it's just shifting your whole distribution. It's not going to change the spread. Okay, so it's going to stay 3.1. Find the new mean and standard deviation if you multiply by 5 and add 10. So for my mean, I'm going to multiply by 5 and add 10, and that would give me 41. For my standard deviation, I'm going to multiply by 5, but the adding 10 is not going to affect it. So my answer is only going to come from 5 times my standard deviation. So I get 15.5. All right, example 5. Random variable y has a mean of 3.4 and a standard deviation of 1.4. Okay, we're going to combine this with the previous example. So random variable x had a mean of 6.2 and a standard deviation of 3.1. Find the mean and standard deviation for x plus y. So the mean of both of them added together gives me 9.6. The standard deviation, both of them added together, so I have to do the square root of 3.1 squared plus 1.4 squared. Okay. You cannot just add the standard deviations. Okay, you have to add the variances and then take the square root. Find the mean and standard deviation of x minus y. So 6.2 minus 3.4 gives me 2.8. For standard deviation, even though I'm subtracting, it's always going to be adding when you're under the square root. Okay, you're squaring everything, so those minus the negatives not going to make any difference. Okay, so it's always just addition for standard deviation. Find the mean and standard deviation of 2x plus 3y. So I'm multiplying. I'd multiply 2 times my x mean plus 3 times my y mean, and then add them. I get 22.6. For standard deviation, I would do the square root of 2 times my x mean squared plus 3 times my y mean, or my y standard deviation, squared. And that would give me 7.489. Find the mean and standard deviation of 3x plus y minus 4. So I would do 3 times my x mean plus my y mean minus 4, which gives me 18. And for my standard deviation, I'm not going to worry about that minus 4. That's not going to change anything. But I'm going to do the square root of 3 times my x standard deviation squared plus my y standard deviation squared, and that gives me 9.405. All right, your turn. A new game. A single die is rolled and the following occurs. If you roll a 6, you get 40 points. If you roll a 4 or a 5, you get 10 points. If you roll a 1, 2, or 3, you get 0 points. Write a probability distribution. All right, so if you roll a 6, you get 40 points. So x is 40, and the probability is 1 out of 6 because there's only one 6 on the die. If you roll a 4 or a 5, you get 10 points. So you have 2 chances, 2 out of 6, of getting a 10. And if you roll a 1, 2, or 3, you get 0 points. So you have 3 out of 6 chance of getting 0. So there's our probability distribution. Now find the mean and standard deviation. Okay, so if you plug that into your calculator, the mean is 10 points and the standard deviation is 14.142 points. Suppose the points are doubled. Find the new mean and standard deviation. So the mean, I would just multiply by 2. That gives me 20 points. And the standard deviation, I would do the square root of 2 times my standard deviation squared, which gives me 28.284 points. And then suppose the game is played twice independently. What is the mean and standard deviation of this? Okay, so the mean would be x plus x, so it would be 10 plus 10, which gives me 20 points. And then my standard deviation of x plus x, it'd be the square root of 14.142 squared plus 14.142 squared, which also equals 20 points. All right, that's it.